This is Unit 7.7, Solving Right Triangles. This is the last lesson of Unit 7, and in this lesson we're going to put everything together. So all of the different methods you've learned to find the sides of right triangles, plus we're going to learn how you can use the sine, cosine, and tangent functions to solve for the angles. So we would use the ratios if we were given the angles to find a side length. But now we're going to be using the inverses of the sine, cosine, and tangent to find the angle. So I want you, before we start, I want to just tell you where to find these buttons on your calculator. So please make sure you're following along with your own calculator so that when you get to the problems, you know how to do them. Okay, so I'm going to go ahead and clear my calculator screen. And the sine, cosine, and tangent buttons are right here. So above them in blue, you see sine to the -1. That means sine inverse. So we have sine inverse, cosine inverse, and tangent inverse. So it's kind of like the square and the square root button. So if you look here, the square root button is the blue version of the square button because those are inverses of each other. All right. If you knew about logs, log is the inverse of 10 to the x. This is the natural log. It's the inverse of e to the x. You'll learn about those in Algebra 2. All right, so these are just the inverses of each other. So we use the inverse if we are given all of the side lengths, but we want to find the angle measures because that's what the inverse of what the regular sine, cosine, and tangent functions do. So whenever you use the inverse function, you don't plug in the angle measure into it, you plug in the ratio, right? And then it gives you the angle measure. So, for example, if I did the sine inverse of 1, which would mean, well, 1 wouldn't make sense. Let's do 1/2. So that means the opposite side would be 1, and the hypotenuse would have a length of 2, and it would give me 30. This means 30 degrees. Okay, let's say I plug in a sine that is a 2/1. So opposite side is 2, and my hypotenuse is 1. It gives me an error because, think about it, your hypotenuse has to be bigger. So whenever you use the sine and cosine, it always is going to be a fraction that's less than 1. But tangent doesn't matter because the opposite and the adjacent, one can be bigger than the other. So anyways, let's look at some definitions. So problem solving methods. So solving right triangles means finding the measure of all 6 parts, all 3 angles, all 3 sides. So for the 3 angles, you have the one that's right, and you have 2 acute angles. For the sides, you have 1 hypotenuse, and you have 2 legs of your right triangle. Okay, you can solve a right triangle if you know the right angle in any of the following. So if you know the lengths of 2 sides, okay, you would use in that case, you would use the inverse functions to find the angles. And you could use Pythagorean Theorem to find the other side, the third side. If you know one side and one angle, or if you know one side and one trig ratio. Because if you know a trig ratio, then you can use the inverse function to find the angle. All right, so methods for finding the legs of a right triangle, you can use the Pythagorean Theorem, you can use trig ratios, and you can use special right triangles relationships. Okay, so remember your 45, 45, 90 is x square root 2, and your 30, 60, 90 is x square root 3 and 2x. Okay, make sure you have those written down somewhere conveniently because remember that quizzes and tests are always open note, so you could use those on your test. Also, I don't think you're taking your air test this year, but those relationships are given on the air test formula sheet. So that's why I just let you have those. Okay, So the inverse trig functions. Oh, wait a minute. Hold on. Define the angle measures. You know that the sum of angles is 180. So if you know two angle measures, then you can subtract them from 180 to get the third side. And we can use inverse trig functions. So let's take a look at those. All right, so if you know that the sine of an angle is equal to x, which x is going to be your ratio, so something over something or a decimal, then sine inverse of x equals the angle. So sine inverse of the ratio is equal to the angle. Cosine inverse of the ratio equals the angle, and tangent inverse of the ratio equals the angle. So that's how you would notate that. Let's look at an example. So this is technically example 1, but angle A is acute angle. Use the calculator to approximate the measure of angle A to the nearest tenth of a degree. So we know that the tangent of A is 0.7, sine of A is 0.9, cosine of A is 0.1. So what we're going to do is we're going to take the tangent inverse of 0.7, and that'll give us the angle. And then we'll do the sine inverse of 0.9, and then we'll do the cosine inverse of 0.1. All right, so let's go ahead and take our calculator. So tangent inverse of second tangent 0.7 gives us 30, let's see, round to the nearest tenth, well, that would be still 35.0 degrees. And then second sine, to get sine inverse of 0.9 gives us 64.2 degrees. And then the cosine inverse of 0.1 gives us 84.3 degrees. Okay, so I wanted to talk about something else as well. So I want to draw these triangles. I'm going to draw a triangle. So this means, and we're going to actually give a possible side length. So here's the right angle. Here's angle A. And for this triangle, so we want to think about 0.7 as a ratio of the opposite over the adjacent side to this angle A. So how can you think of 0.7, which is a decimal, as a fraction of opposite over adjacent? What's one way you can think about that? Well, 0.7, as you know, is also equal to 7 over 10. That is one possible side length for the opposite over adjacent. It could also be 14 over 20 or any multiple of 7/10. So I'm going to say that the opposite side is 7 and the adjacent side is 10. Right, so I just wanted to give you like a visual of this type of question, which I have seen on the air test, and there will be something like this on your test. So how about for the sine? So for sine of A, oh gosh, I can just not draw a right triangle. Okay, so there's angle A. Sine is opposite over hypotenuse. So if you have 0.9, that's equal to 9/10. So the opposite side would be 9, hypotenuse would be 10. And then for cosine, all right, this one's not too bad. Cosine, except for the end. 0.1, so 1/10. So this would be 1, and this would be 10. All right, so, and obviously these three triangles are all different because the angle A comes out to be different. If they were the same, then the triangles would be similar. Okay, so let's look at some other examples. So we want to solve the right triangle. So we want to know, what do we have? We have two legs. What do we need? We need the hypotenuse, we need angle A, and we need angle B. So what are you going to use to find it? So if we just need the hypotenuse, then let's just use Pythagorean theorem. So this is not a 3, 4, 5 right triangle because the hypotenuse would be the 5 and it's not. So let's do 4 squared plus 5 squared equals c squared. This would be 16 plus 25, which is 41. And I'm pretty sure the square root of 41 is a prime number, so we will just leave it as the square root of 41. Okay, now to find angles A and B, we would use the inverse trig functions. So let's start with angle B. I would use the tangent because we have opposite over adjacent. So let's say that the tangent of B equals 4 over 5. Now to solve for the tangent, we would take the inverse of both sides. So now we're going to kind of flip these two around and say that the tangent inverse 4/5 equals B. So if I type that in my calculator, tangent inverse of 4 over 5, you don't need to use your fraction button, is 38.66. 38.66 degrees. Now, to get angle A, all we would need to do is subtract 38.66 from 90. So 90 minus 38.66, which a little calculator trick if you weren't aware, is you could do 90 minus, and then there's an answer button on your calculator, which is the negative sign. So you would click second negative, and that tells you, that just plugs in the previous answer in your calculator. So that'd be 51.34, or you could just do it in your head for angle A. And then that's the measure of angle B. Okay, let's look at some more examples. How about for this one? So for here, we're given this angle, so all we need to do to get angle A is subtract 26 from 90. So the measure of angle A would be 90 minus 26, which gives us 64 degrees. Okay, and then to get this side, we could do the tangent of 26, and then to get the hypotenuse, we could do Pythagorean theorem. Or we could do sine. So let's do the tangent of 26 equals 2 over BC. Okay, and this is where we put this over 1, cross multiply, so BC is going to end up being 2 divided by the tangent of 26, which you practiced in your previous lesson. So 2 over tangent of 26 gives us 4.1. So you could either use Pythagorean theorem here, or if you wanted to be a little safer, you could use the sine function. Because what if 4.1 is wrong? And you'd be using the wrong answer to get another answer. So I'm going to use the sine of 26 equals 2 over opposite over hypotenuse, so 2 over AB. Okay, here, same method, cross multiply and divide by the sine of 26. So AB is 2 over sine of 26. So 4.56. Or we'll just do 4.6, round to the nearest tenth. All right, so we found all 3 sides and all 3 angles of this triangle, so we solved the right triangle. Okay, here's another example. The cosine of h is 0.4231. So let's solve. So let's get angle h by taking the inverse cosine. So cosine inverse of 0.4231 cosine inverse of 0.4231 is 64. I'm going to call that 97. Actually, yeah, let's call that 64. Let's just call it 65. That's what I have in my notes. Okay, so 65 degrees. That's fine. And then For G, you can subtract that from 90. So that's the measure of angle H. It might be helpful to like box your answers here. So the measure of angle G would be 90 minus that, which is 25. All right, now to get either one of these sides, we could use one of the sine or cosine ratios. So to get GJ, we would use sine. To get JH, we would use cosine of angle H. I'm going to do the sine of H, which is 65, equals GJ over 13. So we would take 13 times sine of 65. And then for cosine, we would do cosine of 65 equals HJ over 13. So multiply by the 13. Okay, so I'm just going to type both of those in my calculator. So we've got 13 sine of 65, and then 13 times the cosine of 65. Hopefully I'm not going too fast for you. If I am, just pause the video, stop and think, rewind. So 11.8 and 5.5. 11.8, 5.5. So we have all three sides now and all three angles. All right. Here is this the last example? Yes, okay, so one more example. Thanks for hanging on with me. So solve for the right triangle. So here we have a different kind, it's very similar to that other question, except now they're giving us an actual ratio, and if you notice, the hypotenuse is 13. So this number represents the hypotenuse because adjacent over hypotenuse. So therefore, you know that the adjacent side to angle H, okay, angle H is 5. So you can say this is 5. And then to get GJ, you could do Pythagorean Theorem. So a little trick for Pythagorean Theorem, if you know the hypotenuse and you're trying to find a leg, you could do the square root of the hypotenuse squared minus the other leg squared. So that'd be, I'm just going to do the lazy way, type this in my calculator. So square root of 13 squared minus 25 gives us 12. Okay, so that's actually a Pythagorean triple if you didn't notice it. So this is 12. And then to get angle H, you would take the cosine inverse of 5/13. Cosine inverse of 5/13. And that gives you 67.4 degrees for the measure of angle H. And then to get the measure of angle G, what would be the appropriate step? You will subtract angle H from 90. So do 90 minus my answer, 22.6. And we solved the triangle. Okay, we found our missing sides here. We found both of the angles. And so the point of this lesson was to kind of put everything together that you've learned about using the sine, cosine, and tangent functions, and also learning about the inverse of those functions to find the angle measures, right? So I hope you enjoyed this lesson. It's the last lesson of this unit, so I hope you guys have a great day.